All right, so Marty is back, and we're trying to figure out if he's gonna make it back to the future here. So, given some information, after accelerating for 20 seconds, a DeLorean has a wide range of speeds. The distribution of the speeds follows an approximately normal distribution with a mean of 80 miles per hour and a standard deviation of 7.7 miles per hour. So we've had the mean and standard deviation, been dealing with that a lot. Okay, so this first one is what percent of runs will be less than 70. And so we're looking at a sketch here. And we put our 80 there, and I'm looking at just 70. Remember, it just has to be relative to that, and we are looking for less than. Okay, so go ahead and pause here and find this answer. This is what we did in 2.5, so just a nice little review at this moment. All right, so as you worked through this, we got 70 minus 80 over 7.7, which gave us negative 1.298. All right, we always want to round to two decimal places, but that 8 rounds that 9 to a 10, so that rounds the 2 to negative 1.30. And then we have experience with this. You go into the table, and we get 0.0968. Move that, and we get 9.68% of the time he'll have runs less than 70 miles per hour. Now, as we look at 2, Marty had a not so great run that was in the 35th percentile. So remember, percentile means any values less than that. So he was in the 35th percentile of all possible speeds. What speed is at the 35th percentile? Now, here's a nice important hint. We're going to try working backwards. So now we still want to draw our sketch. We're at 80, and we know we want 35th percentile. So we don't know what that value is, but I do know if I come to 80, that's 50% of the data, so we know we're less than that. So anywhere in here, and we have this shaded area, and that is 35% is found there. We don't know what our value is there. So as we look in our Z value minus mean, which we do know our mean is 80, and our standard deviation is 7.7. Now our Z is not our percent. Remember, our Z score, if we had our value, we take our Z score, we go to our table, and that gives us our percent. So now we have the percent, and we need to get our Z score so that way we can solve for any of those values there. So let's go take a look at that. So that 35, right, becomes 0.35 for what we're looking for. So we'll go to the table down here, and as we trace this, right, so I start in this column here, and I go down, and you'll get better about knowing kind of where to start. But I want to travel down until I get to a value that's right around 0.35. So in between those, and when you're in the negative, it goes down as you go to the right. So I'm going to work this way. I want to find the one that's in between. So that takes us all the way to the edge here. So we are between those two values. We got to figure out which one we're closer to. We're never going to be that exact, but we'll find the one that's closest. So this one, okay, is that 20 away. And this one, to get to there, we add 17. Okay, so this one ends up being our closest one to 0.35. And then we work out from there. So my Z-score is negative 0.3. And we go up to 0.9, so we have a negative 0.39 for a Z-score. So we take that back up to here. We have negative 0.39 as a Z-score. Then our value is our unknown, so we have X minus our mean, which is 80, over the standard deviation, which is 7.7. From there, we just solve. So what we can do is clear that fraction by multiplying by 7.7. That drops out. and I get negative 0.39 equals, sorry, we multiplied, I forgot to add that in, becomes a negative 3.00, I believe 3. So we just leave it as a negative 3.0 and x minus 80. Add the 80 over, and x equals 77. So we get 77 miles per hour is the speed at the 35th percentile. All right, 3. In order to compete in the California Classic, Martin needs to be in the top 10% of speeds. Which score would qualify him for that event? Again, draw your sketch. So there's 80. Top 10% is going to be over here, right? The top end of this. So that is 10% there. Now, we go 0.1 to convert it, but as we go, remember our table shows the left side, but we are currently looking at the right side. So we need to figure out what percent this is over here. So that is 100 minus that 10. So that blue is that 90%. Which then we convert that. So we're looking for 0.9 this time. So let's go to our table. As we go down this, we get to 0.5 there. So then we need to continue on to our next one. And then this one picks up pretty quick. There's 0.90. Again, now notice as we go to the right on this one, it increases. So we'll backtrack. And I want to find between 0.9. So we're between those. And you can nicely see that this one is really close. It's 0.0003 away, not 0.015 away. So we'll go with that one, work backwards. This is 1.2 and 0.8. So we'll use 1.28 this time. So then our z-score is 1.28, which equals our x minus 80 over 7.7. Again, you're going to solve, clear that fraction, multiply by 7.7 to both sides. And we get 9.86 equals x minus 80. Add your 80. And x equals 89.86. So 89.86 miles per hour is the speed that would get him at that top one. Now 4, we're looking at Biff's run, which was in the middle 40%. So a little different here. There's the 80, and we want the middle 40. So somewhere in here is going to be 40% of our data. Well, we need to figure out where those are at. Well, we know at 80, at our mean, that's 50. So if I want 40, that means I'm going to go 20 on this side and 20 on that side, because that gives me 40% between those two. Well, if I'm at 50, if I go 20 this way, that puts me at 30. If I go 20 that way, that puts me at 70. So we have two percentages we're looking at, right? We're looking at 0.3 and 0.7, 0 on both. Now, the nice thing is there's going to be a little symmetry that works here, that you don't have to do that much work in finding these. And we'll see this here in a second. So we get it down. We're looking for that 0.3. So that's going to be less than 50, so somewhere in here. Then we go across, and we end up between those two right there. This one's 15 away, that one's 19 away, so that becomes our answer. So we get negative 0.5, and then we scroll up here, 2. So we're at negative 0.52. And so for the left side, for our 30, we get negative 0.52 equals x minus 80 over 7.7. And then we got to do our 0.7, so we're going to be on the positive section. All right, so I'm looking for 70, so there. And we're working our way up. And then this one falls between those two. So our difference of 15 or 19, so that one works. And look at that, 0.5, 0.2. So this one we're at 0.52, which is the same value, just the positive version of it. And that's that symmetry, because remember, a z-score is the number of standard deviations away from the mean. Well, if we're going the same amount left and the same amount right, then that distance from the mean is going to be exactly the same. We're just going to have a negative and a positive. Now, unfortunately, you still have to solve separately, because when you multiply and then add, you're going to get a different value when it's negative 0.52 as opposed to positive 0.52. But as you work that out, as you saw above, same process. So we're going 76 there and 84 there. So Biff had a run between 76 and 84 miles per hour. All right. All right, so there's your tables again. Go ahead and copy this work down here. You can pause this, because I'm not going to talk all the way through here. All right, and then notice, all right, so in both ones, you're going to sketch. We're going to identify what percent we're doing. The reason or how we do that is, again, as we're with that sketch. We have these two grouped together because we don't have to subtract from 100 like we do on when we're finding the right percent. The less than is easy. We just have that value. The middle one, we're going to find 2, but it's split evenly around the mean. So remember, if we just find 1, we're able to find the other because it's just the positive version of it. Then steps 3 and 4 are the same there. All right, work through 1, 2, and 3 here. A little hint on 3 because it's a little unique of this Q1, Q3. As we look at it, right, our mean is there in the middle. And then Q1 is over here. Q3 is over here. And remember, Q1, 25% of our data is included there. And Q3, 75% of our data is here. So the other way this question could be asked is we're finding the middle 50%. And at the end, remember, you're being asked to calculate the IQR. And so a little hint thing about how you calculate the IQR there. All right, so work through those problems there. Pause this as you work through. And then I'll bring these up as your solutions with the sketches that go with it. All right, but you still need to do the work with that. All right, you'll have some practice as well to go along with this. And then on Friday, we'll clean up any issues or mistakes you may have.